Imagine being a scientist back in the late 19th century. You're walking around feeling so totally smug, thinking you've got the entire universe completely figured out. You think it's this flawless, predictable system. But then, you heat up a piece of metal. Suddenly, the math says this glowing metal should spit out infinite ultraviolet light. Total, impossible chaos. They called it the ultraviolet catastrophe, and it completely shattered their perfect little rules. So this guy, Max Planck, tries to fix the math. He makes this desperate, wild guess to chop energy up into distinct little packets called quanta. The hilarious part? He thought it was just a fake math trick. He didn't even believe it himself. But nature was like, nope, you're actually right. Energy really does come in chunks. And things got way weirder when Albert Einstein took it seriously to figure out how light knocks electrons out of metal. Einstein basically said light travels as tiny, unbreakable particles, which we call photons. Think of a photon acting exactly like a tiny bullet of energy hitting a target. The physics world absolutely lost their minds over this. They hated it. It ruined their cozy idea that light was just a smooth wave. The universe was turning out to be so much stranger than they wanted it to be. And the weirdness just kept spreading. Niels Bohr looks at the atom and realizes that, according to the old physics, electrons orbiting a nucleus should instantly crash into it. By the old rules, solid matter shouldn't even exist. So Bohr casually forces electrons into these fixed, bizarre orbits where they aren't allowed to exist in the spaces between. Just like that, atoms became stable. Okay, here's where your brain is going to hurt. When electrons move between these paths, they basically just vanish from a path and instantly reappear in another. They absorb or spit out a photon, but they never actually cross the physical space in between. They just vanish and reappear. It makes absolutely zero logical sense to us, but the microscopic world just plays by totally alien rules. If you thought that was wild, Louis de Broglie comes in and flips the whole script. Einstein said light acts like particles, right? Well, de Broglie argued that solid particles actually act like waves. When they shot electrons through tiny slits, the electrons didn't act like solid matter at all. They created an interference pattern, exactly like ripples overlapping in a pond. Basically, everything you think of as solid is an illusion. This bizarre new reality sparked a seriously bitter rivalry. Werner Heisenberg hated the idea of drawing little pictures of atoms, so he built this crazy new math using pure, abstract numbers. Erwin Schrödinger couldn't stand that abstract math, so he wrote a famous equation for matter waves instead. They despised each other's work. Then, Paul Dirac casually saunters in and proves mathematically that these two bitter rivals were saying the exact same thing. But this new math didn't bring certainty, it brought pure probability. Max Born realized these waves don't represent physical stuff at all. They just represent the odds of finding a particle. Physics could literally only predict chances. Just let that breathe for a moment. The absolute, predictable certainty of the universe, completely dead and gone. And it gets worse for the control freaks out there. Heisenberg figures out this uncertainty principle, proving you literally cannot know a particle's exact position and momentum at the same time. Measuring a single property actively destroys the other. It's not that our microscopes are bad, it's a fundamental limit of reality. Nature is actively hiding its secrets from us, making us, the observers, a core part of the glitch. Einstein absolutely hated this random dice-rolling universe. He was convinced nature had to have strict, logical causes. At the famous Solvay conference, he went head-to-head with Bohr, hurling these genius thought experiments to try and break the quantum rules. But Bohr was ice cold. He calmly dismantled every single attack, keeping this wild, probabilistic universe alive. Einstein didn't give up, though. He launched a massive attack by proposing quantum entanglement. This is where two particles share a single fate, and measuring a particle instantly affects the other, even across the universe. He called it spooky action at a distance, thinking it proved quantum theory was broken. But Bohr just shrugged and said, reality is different now. Think of entangled particles like two magical dice. If a die rolls a 6, the other instantly rolls a 6, no matter how far apart they are. The physical space between them just doesn't matter. Eventually, the scientists just got tired of the philosophical headaches and shut up to focus on the math, because the equations were flawless. And thank goodness they did. This math unlocked the secrets of chemistry. It showed us how to build semiconductors to push electrons through crystals, leading to tiny transistor switches. It shrank computers from the size of a living room down to the phone in your pocket. basically birthing our entire modern world. Just think about the wild miracles born from this weird math. Quantum light gives us lasers to scan our groceries and carry our internet. Cracking the atom gave us nuclear power with its immense energy and terrifying weapons. We've got MRI machines using quantum spin to look inside the human body and save lives. Even GPS satellites rely on atomic clocks counting microscopic quantum leaps so you don't get lost on your road trip. But all that tech didn't solve the underlying mystery. Decades later, a guy named John Bell circles back to Einstein's spooky action. He actually writes a mathematical theorem to test reality itself, figuring out a way to physically measure entangled particles across massive distances. He took pure head-in-the-clouds philosophy and turned it into an actual physical experiment. And the test results? They proved Einstein completely wrong. Particles actually do communicate instantly. The universe is not locally real. Everything your common sense tells you about how the world works is basically a lie. And the underlying reality of our universe is totally alien. It's genuinely mind-bending when you let yourself really sit with it. This strange alien connection is sparking a massive new revolution right now. Normal computers use bits, which are either 0 or 1, but quantum computers use qubits, which can be 0 and 1 simultaneously. By treating these weird quantum states as raw information, we're unlocking processing power that is honestly unimaginable. This upcoming technological leap is going to be insane. Sure, quantum computers will probably break modern encryption, but they'll also simulate complex molecules in seconds to cure diseases and invent crazy new materials. Plus, that spooky entanglement, it offers completely unhackable communication guaranteed by the literal laws of physics. The future of the internet is totally quantum. Yet, even with all this power, physicists are still fiercely fighting over what the math actually means. Some are all in on the many worlds theory, where the universe splits with every single choice and parallel realities exist. Others think there's just a mysterious hidden wave guiding the particles. The craziest part is that the math works perfectly without ever explaining why. The grand mystery is still totally unsolved. And this isn't just about microscopic stuff either. Quantum mechanics runs the stars. The only reason the sun shines is because protons use a quantum trick called tunneling to fuse together. Without it, the universe is pitch black. Microscopic quantum jitters in the early universe are what actually grew into massive galaxies. Even the literal bonds in your DNA rely on these rules. Our very existence is entirely powered by these quantum events. There is a massive, annoying problem, though. Quantum mechanics totally breaks down when it comes to gravity. Einstein's relativity and these quantum rules just hopelessly clash. The massive scale and the microscopic scale contradict each other perfectly, keeping physics painfully divided while scientists desperately hunt for a unified theory. Think about it. A century ago, we thought we were just measuring nature, but quantum mechanics forced us to realize what nature actually is. Reality isn't fixed, it's just a shifting, shimmering set of probabilities. We traded the comfort of absolute certainty for absolute power over matter. It's honestly pretty funny when you step back. Our human biology literally evolved to understand how to throw rocks and track animals. We were definitely not built to understand invisible probability waves. And yet, human curiosity pushed right past those biological limits to map an entirely invisible, totally alien world. We use these completely bizarre rules every single day to run our totally ordinary lives. The struggle to understand the quantum realm is far from over, but it's a wild ride. Are you ready to leave your old certainties behind and embrace a reality of pure chance and connection? If you loved having your mind blown by this universe today, do me a huge favor, smash that like button, share this with a friend who needs an existential crisis, and subscribe for more deep dives. Catch you later.